we had some questions about maxima and minima and concavity and inflection points and so forth. So, drew a graph, have a scale, negative 10 to 10, or 15 here, negative 10 to 10 here. Here's a curve. Ask people to identify and estimate coordinates of the relative maxima and minima, stating that a relative maximum is a place where the graph is higher in some interval around the point than any other point. Okay, so there's an example. This point is higher than any point immediately to its right or immediately to its left. And same here. So we asked people to estimate the coordinates of those points. We got good estimates. I estimated negative 1.55 here. I think I did that one. And then people made their estimates here and here. So we got relative max here, relative max here. Relative minimum is a point that's lower than any point on to its right or left, to its immediate right or left, in some neighborhood to the right or left. And we have one here at the point 6,3. I'm not going to read the coordinates to you. You can verify the coordinates are reasonably estimated. Then we started talking about where's a function increasing and where's it decreasing. Actually, before that, we talked about where the function, okay, we talked about concavity. Sorry, getting ahead of myself. Okay, at this point, the function is concave down, and the way I describe that is if you cup your hand to fit the function, then the palm of your hand is facing down. Okay, then that's concave down. So at this point, we're concave down. At this point, if you cup your hand to mimic the curve of the function, your palm is pointing up, so it's concave up. Now that's just one of many ways to understand the terminology of concave down and concave up, but either one of those works. Okay, then we see that the relative max here is concave down. Then we say, well, between this point on the curve and this point, we're concave down here, we're concave up here. If this curve is smoothly varying, continuous and smoothly varying, then it's got to be some point where it goes from concave down to concave up, at least one point between here and here. Okay, so where does that happen? Well, it turns out there's just one point. We're concave down till about here, then we're concave up after this, and at this point, if you were to zoom in very closely in the graph would be about straight. Of course, that's true no matter if you zoom in far enough, any graph looks straight. Any smooth, continuous graph looks straight. But you can see that this curve straightens out right about here. And people gave estimates. I got a couple estimates. One of the estimates was that the point was 1,4. The other estimate was 1.54. Well, people looking at this on a zoom screen, 1.4, 1.54, I can't tell you which one's more accurate. I'd have to subdivide this interval, put a good scale on it. And if I did it by hand, I still wouldn't know. Excuse me. Fall allergies. I hope that's all it is. You might want to back up a little bit, not sure. Okay. I haven't missed a class due to illness, and this is starting the 48th year of not missing any classes due to illness. So, it's probably the allergies. Okay. So here is the point at which you go from concave down to concave up. We go from concave down to concave up. A point at which that happens is called an inflection point. So we say there's an inflection point at x equals 1. The inflection point, the coordinates are 1, 4, according to this estimate. I chose that over 1.54 because I have limited space here. I don't have to write another symbol. Okay, Then what other inflection points? Well, people pretty quickly identified an inflection point between here and here. We go from concave up to concave down. Where your concavity changes, you have an inflection point. Fairly simple concept once you see it, and hopefully you do now, if you didn't before. Talking a little bit more about maxima and minima. Okay. There's an absolute maximum and an absolute minimum on the domain on which this function is graphed. Absolute maximum is a point where it's highest. Absolute minimum is a point where it's lowest. Well, clearly we have an absolute minimum here. That's the lowest point. Now that's an absolute minimum. It's not a relative minimum because the function is increasing at this point. Okay? It's not higher than any point in its vicinity because you don't know what happens to the left of this point. It's not lower than any point in its vicinity because you don't know what happens at its left. This is not an absolute maximum because there are higher points, like here. This is the highest point, so this is a relative max, also an absolute maximum, and of course the function's concave down, as we said. There was another inflection point, that's right here, went from concave down to concave up. Okay. Then we ask the question, what x intervals is the function increasing and what x intervals is it decreasing? Well, looks like it's increasing here and continues increasing till we get to this point. So it looks like on the interval -10, -1.5, the function is increasing. Now it's not increasing at -1.5. At this point, it's going down if you go to the right, it's going up if you come at it from the left. So it's neither increasing nor decreasing. So when we express the interval, it is increasing at -10, so we include -10 using the square bracket. But at -1.5 we use an open bracket because it's not actually increasing at that point. So the interval in which it's increasing is the half open interval, -10, -1.5. Then it's decreasing from -1.5 to x equals -1.5 out to here. If the x coordinate of this point is 6, then it's decreasing on the interval -1.56. And you notice that I've color-coded those intervals. Here's the interval where we're increasing. Here's the interval of the x-axis where we're decreasing. That's an open interval because it's not decreasing at this point. It's not decreasing at this point. It's doing neither at each of those points. Okay, then starts increasing again, continues increasing to this point. So it's increasing, I don't know if I even wrote that, but it's increasing on this interval, which you can estimate. Then it's decreasing from here to here. I don't think it ever quite levels off. So there we have it. So there are the intervals. Okay. And I think people understood that because, as I said, everybody in the class appears to be doing quite well. And I didn't have any questions on it. So if you have a question, please let me know. Otherwise, there we have it.